I'm Alexandra Kreis, and you're listening to Outer Travel in a Journey. Journeying now for 30 years into the life and practice of yoga, I have met many who have taken interesting turns, went past extraordinary bumps, and reached unexpected places. People with whom I shared conversations about everyday struggles, intimate realizations, larger questions, ideas, and dreams. So today, I'm passing on the mic to one of them so we could hear and celebrate the wisdom in people's differences and experiences. Hello, and welcome back to Outer Travel in a Journey with Alexandra. And today, special two people on my show. Hey, Ulli and Daria, welcome.
Hey, Alexandra.
Hello, thank you.
Hey, just a short introduction to know who you're talking to, who I am talking with. This is a conversation that I'd longed to have for a long time. Daria and Ulli are working in the same trade. They're both teachers in schools and help younger people to understand the world of physics and math. And as you know yourself, it can be, some people hate mathematics because they never kind of understood it, and therefore it still divides some of the creative people from the scientists immediately. But I think as I noticed these two people in my life, these two teachers, I have noticed that they both have something in common, which is they know where students fall in the curiosity around these subjects, and then also in the understanding. So Ulli, you wanted to start with something that you observed of late, and then we kind of get into the conversation.
So what came into my mind just before the talk was a kind of contradiction. For me, it's contradictory that physics and math are some of the most fundamental sciences that we have to understand the world, and which explain the universe, or try at least to explain the universe, how it works. So then comes the contrast that it's of very low interest in schools, physics and mathematics. Like you said, I hate math. I'm not able to do math. I'm too stupid, and come all these things. And maybe we can talk or start to talk with this, starting with this contrast.
And I think from my end, I think it goes beyond even a disinterest, but I feel a fundamental fear of it. And even physics more so, very often it gets the glaze of, oh no, I didn't do well in physics. Like it's another camp of people.
Yeah, it's this self-programming that goes on and on. I mean, I take the people now in grade 11 normally, so when they're already 16, and these self-talks, I'm not good in math, I'm not good in physics, I don't understand that, are so strong at this age already that it's not easy to get them interested again. And it's exactly what you say, it's the fear. They always, so many of them failed in math, they failed in physics. And this failure is maybe the biggest reason why also the joy is gone. But into the subjects.
Absolutely. And it's interesting what you said to me about it being something that's so fundamental to understanding the world. And I dare say I've always said we pick up on the attitudes and the resonance that we get from those around us. And I would like to question who it is that first introduces students to these topics. I was once told that the simpler an explanation that is required, the more of an expert you need to introduce it. And I do not believe in to my knowledge, in a lot of the education systems around the world, these subjects are not introduced to students by people who are comfortable and knowledgeable with those topics. And I really think it comes down to something as simple as that.
Completely right. It starts in an very early age, doesn't it? I mean, I see my daughter, she had, as most of the kids eventually as very young in the kindergarten, or then they play all these mathematical games, and they do it with a big joy, and numbers are very fascinating for them. And something gets lost on the way. And I totally agree with you that you say you have to make it as basic again as possible. Just 2 days ago, I had with my 12th graders, I even have no idea how we came to the subject. And the question, what are dimensions? What dimensions? So what is zero dimension? What is a point? It's a mathematical and it's physical construct, but what is that? Does it really appear in nature, let's say, as a singularity in a black hole, and then they are already interested in this concept of zero dimensions? I think it came up because in the next year we're talking about vectors and three-dimensional geometry.
Okay.
I brought that up, and so we came to the dimensions. And what is one dimension? It's a straight line. Does it appear in nature? Do we have a straight line in nature? 2 dimensions. Do we have a really flat 2-dimensional surface? Like, and we talked about a shadow. Maybe a shadow is something like that, but that's the only thing that came into our minds.
Yeah, that's absolutely excellent. And I think it's such an incredible bridge point at that point between math and science, because when you talk about flat, then it's so fun and easy to spin off into something that appears flat. When you take your microscope, what is it really when you start zooming in? And then it just completely can then spin off into what is a force, what is a frictional force. And you're absolutely right. That is when students start getting interested.
That's exactly, that's where they get hooked. And in my experience, these moments, they never appeared when I planned them.
You can't plan them.
Very, very, very seldom when I planned them. They came out of a conversation, and what I think out of an openness, of an open space. So what I try to create again and again in these lessons, I try to create an open space where just talking starts about anything, just to come into conversation. And in this conversation, and in their curiosity, which is naturally there between the age of 16 and 20, definitely, you want to understand the world. The world is so fascinating and opening up. So out of this opening space, all the good ideas come and all the fun comes. And there's time enough, and even in our school system, even when we look at the curriculum and when you see of the traditional methods, how ineffective they are, maybe effective.
Yeah, absolutely. And I think that's why I was drawn to the work with Alexandra, because her theme is creating space, and you can't learn in life, and you can't come back to the fundamentals of how to live properly unless you create the space to do that, unless you create the space to think. And so it's just, it permeates everything and applies to everything. But again, I'm going to bring it back to what we said earlier, is if someone put me into a position to teach something that I was not comfortable with and did not really understand on a fundamental level, what's the odds that I'm going to create the space for an open-ended conversation? I'm going to script as much as possible. And that is probably where you would pull in as many tools and games as possible to fill up every moment of space. And sometimes I feel that's what some of the systems that they want to reduce the courses down such that anybody could teach them. And it has the counter effect.
I want to jump in here for the general listener and for myself. I mean, what you're bringing up are so many dimensions in this conversation. You know, there is the question, yeah, there's the question of, you know, what happens if somebody is immediately alienated by the subject, even though it's been kind of brought along in a professional manner, as Ulli mentioned. You know, like there's schools who have systems that make the subject tangible, but then it becomes intangible for a moment, and that's where you lose students. And then there is the other end of the, what school are you in as a teacher, as, a supporter? What is their idea of how quickly you move somebody forward? What's the quality of the school, and how do they want people to learn? And I think this is where we're coming. And then there is, of course, the question of, can anybody who is not a real lover of, teach any subject like math and physics, if somebody is just an understanding of? You can look into life like that at any point. Like, I mean, you can look at yoga teachers. There's people who teach yoga and they know how to teach a trikonasana. There's meditation teachers that know how to read a script very slowly, but they have no clue on how to open into deeper dimension or how to teach into deeper dimension. So you have that all the time. It's nothing that we can avoid or rule with, I think. But from my perspective, what is more interesting is, like, how can we raise the curiosity, or how have you managed, because I know the two of you do that, how have you managed to raise the curiosity about the fundamentals of life? I leave that to you. Anybody?
Yeah, I think it's, as Uli said, it is about creating the space for open discussions, using an instinct to see where is it a case of disinterest versus where is it a case of potentially fear. And I have even started certain classes where it has been more fear-based and not a history of success, with literally asking students for homework the first night to write down, I'm open this year to learning math 10 times. And they look at me like, you've got to be kidding. I'm like, no, I'm not kidding. And the other fundamental for me, I think, is a comfortableness with being able to estimate answers and to relate them, because that gives you anchor points. And the metaphor I use is, if you are traveling and you travel to a country where maybe you're not fluent in a language, but you know a couple of words, you can make your way around. You may need to use a translator, but you're not lost in the dark. You can get the gist of the conversation, and you have this internal confidence that you're going to be safe. But if you travel to a country where you have zero comprehension and you find yourself in a situation, you are completely dependent on the person translating for you. And if you're doing math and science and physics without the ability to estimate and to visualize what's happening, I feel like you are in that second scenario, and therefore you don't have a chance of building safety and confidence and building a toolbox.
You're working currently, Daria, on a series of articles or videos, I'm not sure, about, slowing down to raise the bar. I really like that incentive you're kind of working on. And
it is, yeah. I thought of that about last year somewhere, and I liked it so much I trademarked it, actually. And that is a project I'm hoping I will start this summer. But that's exactly it, is slowing down and always taking a look at the ability to estimate an answer and to take as many steps as are required in order to see the logical progression of the question, as opposed to taking a shortcut. And I've sometimes heard, well, it's okay, just give them the shortcut because they're not going to be professional mathematicians. To which my metaphor is, but when you teach them basketball, do you tell them that they can travel with the ball and not dribble as long as they put it in the hoop, because they're not going to be professional basketball players? Because I get so frustrated at hearing, oh no, they're it's okay, they're not really good at math. They don't need to see all the steps, and just tell them to take this little shortcut here.
And Ulli, you mentioned also something that I've been reminded of. I mean, I've done my fair share of math, but I always felt a little bit lost in that occasion. And you talked about, there's the one thing that Daria mentioned here, that idea of okay, I can shortcut and I will land some balls in the basket case, but then again, it feels all like good luck. And then at some point I break down around the idea of, and I, like the incapability of understanding things. You were kind of referring to them earlier, because there is no placement in the world with the formulas or why we need the formulas. Can you talk a little bit about that, how you use that? And you're muted, my dear.
And now I'm not muted anymore. So yeah, I agree totally with you, Daria, to engage the students in the full process and not just to come with a shortcut. Although in the aftermath of the long time process that comes before, elaborate process, they can just have some formulas at hand which they can use. They don't need any time again to invent the wheel new. So when they have invented it one time and understood it thoroughly one time, they can use it for the rest in form of a formula. It's
Absolutely, absolutely. But once it's understood.
Yeah, right. And the fun is in the understanding, not so much in the use of the stuff. The fun is really in how does it work. It's so fundamental in us. We want to know how this world works. We want to know how it functions. So to give this process all the time it needs, it's very important. And the difficulty, you know it yourself. I think you're also working in the conventional school system. You're not at a Waldorf school or some kind of alternative school. So I know a little bit how Waldorf schools work and how difficulties they have when it comes to the final exams, but they manage quite well. And they do this very thoroughly. And they also bring in their own interests. For me, let's say what for me is most important in my whole career is my own excitement for the subjects.
Mm-hmm.
It's very personal, and I see that the pupils react very personal. They react to me as a person, not as a math teacher or physics teacher. But there he comes, we like him or don't like him, but we are interested in this person. And so they are interested also in my passions. And to bring this over, that's for me the most important thing. Like I was in school, I was more or less, I was okay in physics and math, I was quite good, but not so super top. But then I think I was 16 when I read Werner Heisenberg, Der Teil und das Ganze, I think it's translated, The Part and the Whole. Werner Heisenberg, by the way, is one of the discoverers, how you want to talk, of the quantum theory. Mm. And this book, it was absolutely mind-blowing for me at that time. It turned my world completely around, because the word consciousness came into mathematics and physics. And it was like, wow, the consciousness is important. It's not just an isolated science that out there and here I am and I have nothing to do with it. But my consciousness decides also about the outcome of an experiment, the outcome of the world. Yeah. And this triggered me so much that I immediately became much better in school. In the last 2 years, I was very good. I went from quite good to very good. At least in physics and math, not in the other subjects, to be honest. And this interest is still in me so strongly. And when I talk about it with the pupils, I see they even want to talk, that I start to talk about it. And then they come in with their interests. And this is for me the fundamental thing where I always get them.
Yeah.
They're personal.
Absolutely. I sometimes start a year with having students make a slide of, think of a hobby and how does math impact it?
Yeah.
And, I unwittingly, one student, I had no idea she was actually starring in movies, and she seemed very disinterested, and she said, I don't have any hobbies. And I could tell it was just and I said, well, you're French, you must like movies. And totally not knowing. And I just saw her eyes just light up a little bit. And all of a sudden she started thinking about, frames per second, and she thinking about dots per inch. And And all of a sudden, all these things started popping up in her mind, and she went on the next year to take 2 math courses.
Wow.
And I think it
Hmm.
came down to her ability to link the two, like Uli says, is at the end of the day, we're people and we do want to understand our world.
Hmm. So as a closing question, or the last question in this interview, can you, one of you or both of you, say something to the parents that might be listening at this point and thinking, yeah, but my kid is in school and my kid has this teacher and they don't get along, so how can I help my child, who is in the middle of having an aversion to math or physics, to get through the system, because it's the basic as well in most of schools. You have to have math in your finals, and you have to have that as a point that brings you through, because it can, like double up your points in a way that it blocks you from getting your grades. So
I think for me, it just comes down to get curious about your learning. Get curious about how it relates to things, and just always come back to that fundamental of what one of my uncles said, an equal sign. Whatever you do to one side, do to the other side. Just keep it really simple and leave some space for some curiosity and for some love of learning. And then I really feel the rest would fall into place easier. Uli?
Completely right. And never ignore any signs of curiosity in any way. Like this, you're interested in, this doesn't bring you further, you have to do this and that. And a completely different thing, maybe for me, what I have the feeling it always helps also, is when you talk of the plasticity of the brain, and that every math lesson, I tell them, in the end of this math lesson, you have 200 neurons more connected than before. You have literally grown your brain, and this grown cells, they help you also in all other personality questions, my personal questions maybe. If you have problems with your girlfriend, or if you have problems with your parents, you can sit down and you can use this new gained analytical power to deal with it. You don't think just in your emotions, and you're not anymore the victim. You basically get stronger. You get a much stronger brain that can help you also in personal problems. And that I see then the eyes, they start to, wow, yes, it's really true. Okay, we'll train. It's like you train your muscles, and so you train your brain muscles also there.
Yeah.
And they seem to like it. And maybe this is also a kind of motivation that the parents could give them. There are many forms. This worked for me always.
And also, I think also maybe encouraging the parents to discover their own curiosity, even if they did not have a great experience with math or physics, is instead of saying, oh, I was never good at it, I didn't like it either, or just trying to hide that feeling, is just become a student themselves of it, and model just model a spirit of curiosity.
Yeah, and talk with your kids about so fundamental things like, what is space? What is time? What is that? Think about it. Maybe at the coffee table, and start a discussion about that. Even if you have completely no idea what you're talking about, but maybe then come some references from your kid. Maybe they heard something in school, or they looked a video about black holes or whatever, and see that space and time are very strange things that we absolutely cannot understand. And also, what's for me very important to show them that math and physics is not a fixed system, that it's very open and it's developing all the time.
And they're also languages. They're languages
right.
that model things, that communicate and model.
And help us to understand so many things also in our day-to-day life. Maybe there's a black hole around the corner and you don't know in which space-time dimensions you are pulled when you walk next morning to school. To make it exciting, this could all happen. It's not out of thought. So let all your fantasies just grow and develop. It's all possible. It's all backed up in the end by mathematics and physics. Everything is backed up.
Very true. Thank you.
Yeah. Thank you both. What I heard you both saying is like, know who you are and what is your key interest. Come back to what is your key interest in learning. Like, Daria mentioned the person who is interested in movies. And that kind of triggered me in that I saw, for example, the very beautiful made film about Einstein, which kind of like, or a series on Netflix. And it really helped me to understand the relativity theory, which I had forgotten. But the idea of somebody who is in the train, doesn't see the thunder, lightning, while at the same time as somebody who would be far on a hill and observes the phenomenon. And from there kind of, get down into the nitty gritty, because not everything is always fun. We cannot keep everything at a fun level, but we can be inspired by what inspires us first. And the rest is still a little bit of hard work, So that's what I heard you both more or less saying. We can inspire ourselves, and we can be inspiration to others as teachers or as parents who find inspiration for their kids, maybe on YouTube or wherever kind of they find a fun way of learning, songs. We found songs for our daughter to learn the multiplication stuff. And there is a lot out there, creativity out there, but sometimes it's still the effort we have to put into these things, and and the discipline to keep understanding the world. We cannot just be ignorant and consume. I think that is also what we have to acknowledge at this point. And so that would be my final word on the understanding of this conversation, but maybe you both can have a final advice, word, or wisdom you want to share out here.
Well, what just popped into my brain, Alexander, as you were talking about Einstein and relativity, is now it's so easy. So some students say, well, that doesn't apply to me. What if that's not their fun zone? But GPS and everything we rely on relies on that technology. And so for them, just even that little tidbit, all of a sudden it's like, oh, okay, well, it's not as far out there as I may have thought.
Exactly what you said, Daria. It's like without the theory of relativity, you would get lost with Google Maps. You would not have the precision. You would maybe get to the wrong point, in the wrong corner, make the wrong turn. And it's also all because of theory of relativity. It wasn't included, you get lost. So there are so many things. Keep open, be open, beware of getting closed down, stay free and open to the wonders of the world.
Yes, thank you. Let's stay open to the wonders of the world. And there's teachers out there, humans out there that have an interest, and they have quite a good way of, portraying how they kind of developed their understanding and can simplify it. As Daria said, the simplification is the hardest thing.
And if I can just mention one more thing, I think also the connection, the place where I'm going to go with things, sometimes it's so clear to me, I forget to mention it, is how is a question shown in math and how is the same question shown in a science classroom? And I think we can do better showing students how the same question can be presented with seemingly different languages, different letters. And the more we see relationships between how the same question can be represented, I think the simpler everything will become.
Well, yes. And that went straight over my head, to be honest, because that is such an alien language still to me. And I wish I had I know what you said about the GPS and that we kind of depend on these theories. And I think we do depend on a lot of things that people discovered, and not everybody is going to be an Einstein or interested that how the world works on that level, or around physics or mathematics, even though it's the basis on which we grow at times in technology. But it's also okay to have that, what I was saying, you know, to have these gaps, because we all need to specialize in a certain way to enrich the world, but at the same time, stay curious with whatever other people have to offer and how they bring us forward. So thank you both for showing up on this sunny afternoon.
Thank you.
And yeah, dear listener, I hope to see you next time.